For this terminal velocity example, we're going to find the terminal velocity by solving the differential equation and then letting t go to infinity to figure out where the terminal, where the velocity terminates. So here we go. We have m equals 4 kilograms, gamma is 0.5 kilograms per second, gravity from Earth is 9.8 meters per second squared. Write our differential equation is mv prime is equal to negative mg minus gamma v. So write that out. I did change the gamma here just to 1/2. It'll be a little easier doing the algebra. And the next thing, so we want to solve this. So let's go ahead and use integrating factor. I think that'll be a little easier. So this is going to change into 4v prime plus 1/2 v is equal to negative 39.2. All right, and then for integrating factor, we have to get it into the form where it's just v prime plus something times v. So we're going to divide everything by 4. So we get v prime plus 1/8 times v is equal to, this number was negative m times g, and so if we divide by the mass m again, we're just going to get negative 9.8. All right, now I compute the integrating factor. So the integrating factor, mu of t in this case, is e indefinite integral of the thing in front of the v, so that's 1/8 dt. And that ends up being e to the 1/8 t. All right, so multiply that by to the entire differential equation. So we get e to the 1/8 t v prime plus 1/8 e to the 1/8 t v is equal to negative 9.8 times e to the 1/8 t. All right, then we can collapse the left-hand side in reverse product rule. Right, so we'll get e to the 1/8 t times v, the whole thing prime, left a space there for the d, t, right, equals integral negative 9.8 times e to the 1/8 t. And now we're going to integrate both sides with respect to t. So write integral dt, integral dt. All right, so the left-hand side, that one's easy. The integral and the derivative cancel. So we end up with e to the 1/8 t times v is equal to, so this side we're going to have to multiply by 8, right, to cancel out the 1/8 from the power rule going in reverse. So negative 9.8 times 8 ends up being negative 78.4. And then our e to the 1/8 t stays around, sticks around, so 1/8 t, and plus our constant. Right, now if we actually solve for v of t, that's going to be, we'll multiply everything by e to the negative 1/8 t. We'll end up with negative 78.4 plus c times e to the negative 1/8 t. All right, so now to figure out the terminal velocity, I want to take the limit as t goes to infinity of v of t, right? So that's going to be negative 78.4 plus some constant times e to the negative 1/8 times infinity. Well, so e to the negative 1/8, that's right, negative 78.4 plus c, and it's e to the negative infinity essentially. E to the negative infinity is like 0. So then the limit here should be negative 78.4, which is the same answer you get if you use a direction field or you just solve for v prime is equal to 0. And again, that one ends up being, if we all worked this out, it ends up being negative mg over gamma.